Okay, so let's try out one of these inverses with restricted domains. Let's try to find the inverse of a quadratic, of a even function, we could say of a polynomial of second degree, different ways to call this thing. But anyways, we're talking about a parabola. We're talking about something that is going to fail this horizontal line test that'll say that we cannot find an inverted function unless we restrict the domain. So let's go through those steps. So we have our original function, x squared plus 2x plus 4. We're going to replace our function notation with a y. We're going to swap all of our x's and y's to generate our inverse relationship. Then we're going to solve for y. Okay, so we are going to subtract 4 from each side. Let's get x minus 4 is y squared plus 2y. We're going to complete the square so that this is easily factorable. So completing the square on this portion would require a plus 1. So we add a plus 1 on both sides. You get x minus 3 now on the left, and you get y plus 1 squared when you factor it. Okay. At this stage, we can take the square root of both sides, giving us plus or minus the square root of x minus 3 and y plus 1. And we simply need to take away 1 to get y by itself. Okay, so now we have our relationship solved for y in terms of x. And we can replace that y with our function notation once again. And we can say our inverse function is -1 plus or minus the square root of x minus 3. Okay, so that's going to be our inverse function there at the bottom. Now, a few things we need to say. So, if necessary, which in this case it will be, we are going to restrict the domain of the inverse so that it is a function. Okay, so this is our original parabola. This is our inverse image, our mirror reflection across the line y equals x. And if you wanted to kind of focus in on which part is the mirror of which part, this green arrow would be this going up to the right, and this orange arrow came from this going up to the left. So you just want to imagine that mirror going along that diagonal, and you can see which parts line up as reflections of each other. Okay, so because it fails the horizontal line test, f inverse of x is not a function. This guy is not a function over here. Find the restricted domain of f of x so that f inverse of x will be a function. Okay, look for a portion of the graph that's 1 to 1. If the domain of f of x is restricted to everything between -1 to infinity, so -1 to infinity, we're talking about x values here. So the domain is restricted from -1. We'll start here and we'll go out to infinity to the right. So we'll just say we're only going to look at the right half of this original function. Well, if we restrict it to only the right half, then we will get this green portion. We'll get -1 plus the square root of x minus 3. We get the top half here. If instead we restrict it to everything between -1 and negative infinity, then we're talking about the blue line as it goes from the bottom here up to the top left. And that would correspond to the orange arrow, the -1 minus the square root of x minus 3. Okay, so that would be it. You just have to state that you are going to restrict f of x to this domain, and then you could say that you have an inverse function right here, or if you're going to say that I've restricted f of x to this domain, then my inverse function would be written like this. Okay, so you just have to state how you're restricting your domain of the original function before you write out what the inverse would be under that restricted domain. And that is the process for example number 3.